love class. You know, with all our heart, we're sending a Valentine's Day to Stat 100. And so appropriate. Thank you for the rose very much. And it inspires me to look at our romantic data right off the bat. So let's do that and see about our last survey, which was this one. This was survey 1, survey 2. And what did we ask that were romantic questions here? How many people have you been in a serious relationship with? That's a nice one for Valentine's Day. How old were you the first time you kissed someone in a romantic way? How many people have you slept with in your life? Is that romantic? I guess. Depending on how you look at it. I know. How about how strongly you are in favor of gay marriage? For some people, that must be very romantic. I don't think abortion's a romantic one. Let's skip that one. All right, so let's see. What should we look at? Well, we're looking at first of all, when we use, I think so far, we've mostly just looked at histograms. Is that correct? And so, for example, if we wanted to look at the histogram of how many sexual partners you had, we could look at that first, and then we could think about what you might think it would correlate with. Or how many relationships have you been in? Do you want to do that one? Let's do that one. What does that mean? We have to do more bins. Let's see. How about if we go up higher, 32. What are people saying? What were all the answers like? I guess it only went up to 12. So if we did 12 bins, we'd do the bin. I haven't looked at this data. We're sharing it together right now. So if we did 12, 21. Let's look at the stats. Somebody had 25 serious relationships already? How old is this person? How old? Okay, so now what we can do, I've got an idea. Let's go to Scatterplots. And what we'll do is this. We'll think I want to plot two variables. One is how many serious relationships you've had, and the other is how many people you've slept with in your whole life. So help me out here. Which should be on the X? Which one do you think which one would determine which? Relationships. The more relationships you had, the more people you'd sleep with. Okay, let's try that. So on the X, all right, so on the X is going to be the number of relationships, and on the Y, this is the clicker questions. I guess we should ask some clicker about it. On the Y, that's abortion. We don't want that one today. Where is it? Relationships. Why am I having so much trouble seeing these? These aren't in alphabetical order, is why. Okay, so there's the relationships, and then the next one we're going to look at is what? Number of sexual partners. Where is that one? Right here. Okay, so what is it saying? There's a correlation coefficient of 0.4. So you were right. Let's look at the regression line and something else called the standard deviation line. A positive correlation. So whoever thought, that's the person who had, where's the person who had 25 relationships? That person's right up here. Number 458. 25 relationships and 50 partners. It's like a regular relationship and a spare for each one, You got your real one, and then you got one on the side for each one. Very, very consistent. That's what it seems like. All right, so we've got that person. And then, what about the people who have had all these sexual partners and not very many relationships? That's like these people. Just one serious relationship, but 50 partners? It's like looking for a needle in a haystack for that one person, going, really getting down on your all fours looking for it, though, right? Isn't that what it seems like? Where is that one person? I guess you have to get dirty to find it, But anyway, so you can look at this data, and this is a scatter plot. It really helps us understand how the relationship between one variable and another. So what this tells us right here is the people who in z-scores are exactly the same for both. If there's a perfect correlation, everybody would be on this line. But there's not. But there's a positive correlation. You know what this line is? This is the regression line. How many people have heard of that word, regression? Raise your hand if you've heard of it. Regression. People talk about it all the time, and what you should think of the regression line is a line that uses the correlation coefficient, R. It uses R in the regression line to help you estimate one variable from the other. And I'll show you how it works on this data. Let's get rid of let's clean up the data. And what we can do is we can look at everybody. We can divide this up into columns. We'll do what's called a regressogram. But I need a lot more columns. I want one column for each one of your answers. Does that do it pretty well? Yeah, that looks pretty good. So, for the people who had 0 relationships, a lot of you have not had a serious relationship yet. A lot of you haven't. And some of you, let me show you, this isn't just one person here. I have to show you what's called some jitter here. And where can I find that jitter? Right here. See, there's a whole lot of people who answered 0 relationships and 0 people they slept with. That's consistent. There's a whole lot of people there. But there's people who had serious relationship who, as we saw, went all the way up to 22. And what the regression line does is it picks out the average. So if I wanted to estimate, a whole bunch of you never had a serious relationship. Some of you have not slept with anybody. Some of you have slept with as many as 25 people, right? So I want to figure out what would be my best estimate for somebody who has had 0 relationships. What would be my best estimate for how many people they've slept with? Well, I wouldn't take the very bottom group of people, even though there's a lot of them, it's 0. And I wouldn't take the very top person. My best guess would be what? What do you think? The average. Yeah, the average of all those people. Now that horizontal line right there is the average. It doesn't look like the average because it's not that you'd think the average would be halfway here, but it really is the average because look how many people had 0s here. Look how many average people had 0s. So it's pulled way down here, and 1 is the average for them. Similarly, let's look at people here who had, I didn't divide these bins up so good. Maybe I should, I'm so sorry. I think I should have, I'm going to try if I do 35. If each column will have its own little, okay. So now, here's the people who had 1 relationship. And you see how their average is a little bit higher? There are people who had 1 relationship who go all the way up to 50. And I hope he found that 1 relationship and is able to stop, him or her. I hope that was it, Now he found that 1 person. And there, but a lot of people, are way down here. So what does that mean? That they found the 1 person, but they haven't slept with them yet, right? The people who are 0 are in a serious relationship, but are waiting. And then there's ones that have slept with 1 person, 2 persons, and you take the average there. And same all the way up. Now what happens like here? 5 serious relationships, and they're all over the map here, and you can see probably better, there's the average. Of everybody in this class who's had 5 serious relationships, the average number of people they've slept with looks to be about 10. And if there's only 1 point, well, there's only 1 average. Now, what the SD line, what the regression line does, is the best fit through all those little horizontal averages. You can't fit every one of them. If you could, that would be great, but usually you can't. It's the best fit through them. And that's very different than the SD line, which is always steeper. So that's the basic idea there. All right, so should we go back to the notebook? Or before we go, do you want to look at anything else that we have here while we're up here? Any other relationships? I don't mean relation, I mean any other 2 variables, not like any particular relationship. Yes, in the back? People what? And eat at Subway?
No.
GP. Oh, how many people you slept with? Oh, okay. All right, sure. So, the number of sexual partners, which is going to predict which? Do you want the number of sexual partners to, that's a perfect correlation, number of sexual partners predicts your number of sexual partners, but you want it to predict GPA or vice versa? The more people you sleep with, the higher your GPA or the lower? Oh, you can't really see. What is that telling us? It's a slightly positive. It's just 0.1, but it's really not much of anything. Or is it slightly negative? It's slightly negative. It's slightly negative. I can see if I put this regression line in. Yeah, slightly negative. That means that the more people you sleep with, you have on the average, people have a lower GPA. On the average. You know, that's a person who's doing very well in both, very high in both. But there's a person who's a poor person. 0 and 0. Rough life. Yeah, maybe transfer to a different school. Okay, so that's our data there. Now we have to learn. You know what we're going to learn how to do is learn how to make these regression predictions. One way is by getting the equation for this line, but a way that we can do it even more intuitively is by converting to z-scores, the same way we did to figure out how people would be on the SD line. So let's go to our notes and think about good questions for our next survey, okay? And email them to me, because it's the first Friday, so that should be coming up on the first Friday in March. Now, all right, so what are we going to do now? It's so nice. In the middle of a lecture, I can stop to smell the flower. Okay, that's wonderful. All right, so this page might be difficult for you to understand until we do an example, but the idea is this. If there's a perfect correlation, R equals 1 or negative 1, then we can perfectly predict Y from X. So if F starts at the average, I'll draw a little graph here. Let's say, let's say that's the average for X and Y. If you went over 1 standard deviation in the X direction, if that was the average and went over 1 to a z-score of 1, you'd go up a full standard deviation in the Y direction. And every point on here in z-scores would have the same z-score. You'd go up a full standard deviation in the Y. That's what that's saying. We went over that. Now, what happens if there's only a correlation of 0.8? Taking the same picture for 0.8, let's say this was the average. I'll say for X it's 0, And I can say it's the average for y too. But if we went over a full standard deviation in the x direction, 1 SD of x, we wouldn't go all the way up. We wouldn't do what we did here to get to 1, 1. We'd only get part way up, 0.8 of a standard deviation in the y direction. Like if here was the full standard deviation, we wouldn't go that far. We'd only go up 0.8 of the way. We wouldn't go the full way. If there's a perfect correlation, we go the full way, and R would be 1. And the SD, just to show you, the SD of the standard deviation line, this is rise over run. So if you go 1 standard deviation in the x direction, you rise up 1 standard deviation in the y direction. And that's what, if the point of averages was right there, 0, 0, and we went 1 in the x direction, 1 standard deviation. I'm just giving you the concept of it without any numbers. So if you went 1, that would, and 1 in the y, this would be 1 standard deviation in the y, and this is 1 standard deviation in the x. You'd get to this point, which is 1, 1. But if R is anything for the regression line, and this is the SD line, all the points are on here. But let's say R is equal to 0.8. That's what we just did. We wouldn't, if R was equal to 0.8, the points wouldn't all be in a line. There'd be some scatter. Sure, there'd be the people who are on the SD line. Sure, there'd be these people who are exactly the same in both. You're always going to have them. But there's going to be a lot of other people, too, who aren't. There's going to be scatter. And what this is telling us, oh, we have guests. Oh, hello, you're all dressed up. Oh, thank you.
We have a message for Gustavo Rodriguez from Liz Bridge.
Oh, let's see if I can get her on camera. No, I can't. Yeah, come on down. That's okay. Are you going to sing? Oh, good. Do you want a mic? Do you want a mic? Yeah. Here. This you just put right behind your ear, and you can just.
Oh, wrong. Is this the right way?
On your. Yeah, just put it right
This
on
way,
your ear,
huh?
and it will just like.
Around this way?
Yeah, it's like a little bit lower.
Enjoy it.
A little bit lower.
Trying to turn down like here? Maybe?
Yeah.
Okay.
That's good. Try it. See.
Hello? Can you all hear me? Can you all hear me? How y'all doing? Somebody know me in this class. Just call my name. All right. Y'all ready? All right. No pressure, right? Give me a moment. It's fine, I'll hold it. 5, 6. Many guys have come to you with a line that wasn't true, and you passed them by. Now you're in the center ring, and the lines don't mean a thing. Why don't you let me try? Now I don't have a diamond ring. I don't even have a song to sing. All I know is la 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 means I love you. La 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 means I love you. Second verse. If I ever saw a girl that I needed in this world, you are the one for me. I'm gonna hold you in my arms, girl, and thrill you with my charms. I'm sure that you will see. That these things I am saying are true, and the way I explain it to you, listen to me. La means I love you, oh baby. La 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 means I love you. Thank you all. Thank you. Thank you. Thank you.
No, you don't want to do
No, we can't do another one. We have to get to the next. We have a lot of engagement.
Let's give them a huge hand. Oh my God. Oh, wow. Oh, that was phenomenal. They are so talented. And I want to know if that was that a surprise for you, Gustavo? That was pretty amazing. What a nice break. All right, now we should get back to, I know, it's difficult, isn't it? So why don't we just, after that, I think we just have to skip to an example, okay? And you'll get this. You'll get this. All right, we've already done this. Let's get to an example and you'll understand. That made me happy. All right, now, so last time we had the same data, our height and weight data, and we looked at it, I think it was in chapter 6, so correct that. And we looked at it as if it was, gotta get this right there. We looked at it as if, for the SD line, we wanted to know all the people who are 71, 65, and 62, how heavy would they be if they were just as heavy as they are tall? They were on the SD line. I don't know if you remember that, but that's what we did last time. We can take a quick look back just for a moment to refresh your memory on that. And we saw right here that the way that we figured that out was we looked at these people, and they're all in the SD line, and they said, oh, they would have the same z-scores. They would have the same z-scores in X and Y. That's what it means. But then we said there's this other line, the regression line, that actually, if you look at all the people who are 71, all the girls who are 71 inches, we said, yeah, some of them are way up here on the SD line, and they have weights as high as 185. They're exactly as heavy as they are tall, but more of them are lighter. And if we were actually going to do a regression estimate, make a prediction, like without looking at the person, you tell me, some girl tells me that they're 5'11", and I want to make the best prediction. Let's say I was betting money on it. I would never bet up that high because look at the column. There's many more girls who are below that. And same with the girls who are below average in height. These are the girls who are 5'2". There's a lot more of them. They're only one standard deviation below the average. The ones who are just as light as they are short are 110 pounds. They have the z-score -1, -1. But do you notice within this vertical strip, all these girls are 5'2", that on the average they're higher. They're taller than that. And what this regression line does, it's an estimate of the average it's a smoothed out line, it's the best fit through the average for each vertical strip. How can we arrive at that line? Well, the key to that is is right here. Instead of multiplying by 1 to see which girls are on the SD line, we are going to use the information that we got about the correlation coefficient. I didn't get it. And use that to see that, if it was a perfect prediction, these would be girls who are 71 inches, would weigh 185, but on the average, they're much lighter. So how do we get our regression estimate? Instead of multiplying by 1 here, when we change from one z-score to another, what do you think we do? We don't multiply by 1, but what do you think we multiply by? R, right, good. 0.5, terrific. So that's what we'll do here, and then we'll be, pretty much, that's what this chapter's about. Okay, and if it was 0.8, we multiply by 0.8. If it was 0.5, 0.5, negative 0.3, this is how the correlation coefficient figures in making regression estimates. We've already gone over that, so here we are. All right, so let's do the same exact thing. So, this is the regression line, and this is the line that we want this is the best prediction for X, for Y given X. All right, so now let's do it, the same exact thing. So here we are at 71 inches, and the very first thing that we have to do to get from inches to weight, we can't go directly, we're gonna have to go through what? You tell me, what? Z-scores. So we're going to get the Z for height and the Z for weight. And we did that already. We can do it again. We're just going to say 71 minus what? The average, which is 65, divided by the standard deviation, which is 3, and we get 2. Now, we have to take account of this piece of information way up there, that R is equal to 0.5. And notice, for this girl right here, I'm going to draw the picture. These are all these girls who are 71 inches. And they range in weight. We went over 2 standard deviations. We went over 2 standard deviations from the average where the 2 lines cross. And if we went up 2 standard deviations, we'd be right there on the SD line. But most girls are below that. So instead of going up 2 standard deviations, we're going to go up only a fraction of that. And that fraction is R. Instead of going all the way up, because R is 0.5, we're only going to go halfway up to get a z-score of 1. And notice that means this slope of the line it's only half as steep. Half as steep. The slope is only half as big. If R was 0.9, it would be 90% as steep. All right, so this we already have that, but this is the girl we want. This was 185. Our best estimate's going to be less than that. Let's see what it is. What is it? Well, we start at the average here, 135 pounds. And this tells us that we are not 1 pound above average, but 1 what? Standard deviation, which is 25 pounds. So that tells us that our best guess right here for somebody who's 71 inches is not way up here at 185 pounds, but down here at 160 pounds. That's where the average girl who is 71 inches tall in our class weighs that. Does that make sense? And that's called doing a regression estimate. We're using this R value. So let's do how about the 62-inch girls? There's a lot more of them. They're only 1 standard deviation below average. They're all in this column. And last time we saw the SD line is this steeper one, and the regression line is flatter, always flatter. Look how I spelled flatter. I'm so sorry. Regression line is flatter. All right, so we got this point last time on the SD line. That was 110 pounds. But look, most girls are heavier than that. We want this. We want that. We know she's 62 inches. So let's do that. 62 minus what? I've got to get her z-score. 62 minus 65 over 3, it's -1. So in z-score, she's -1. Now, we have to multiply that by 0.5 to get our best estimate. This is the regression. This is the SD. This is the regression. So now, girls on the average who are in that column, all the girls who are in this column, the average girl who's 5'2" in our class is not way down here at 110 pounds, but she's up here at what? 135 pounds minus 0.5 standard deviations. And so that puts her at what? That equals 135 minus 12.5, which is 122.5 pounds. And if you are 5'2" in this class, that probably sounds a lot more reasonable to you than being 110, which is very light. And if you are 5'11", 160 probably sounds a lot more reasonable. Most people are at that rather than being 185. Okay. So this is 62, 122.5 pounds. And in terms of a z-score, it's -1, -0.5. And in terms of a z-score, this is 2, not 2, but 2, 1. And this is all because r is a half. You just multiply that by r. Let's do 65 inches. 65 inches is just right at, come on, you know this one right off the bat. Right at the average is a z-score of what? 0. 0 times anything is what? 0. So if somebody is 65 inches, your best guess would be what? 135 pounds average for both, and that's where the two lines cross. The SD line and the regression line always cross at that point of averages. Okay? All right, I'm wondering if this iClicker, if we've learned enough to do this iClicker question that I have up here. I'm going to try it just to see if we've learned enough yet. I can't remember what it looks like. So I'm going to go over to the PC. Get out your iClickers. Okay, so now, that's nice. Okay, so which line is the regression line? We're going to do this first. One of the lines is a regression and one is the SD line. You have to decide which is the regression line. All right, I'm going to, how do I get back? Whoops. Back up, there we go. Okay, so I'm going to start this right now. We're doing this one. The first question, which is the regression line, A or B? One is the regression and one is the standard deviation line. Remember, the regression line is always what? Flatter. right, anybody need more time? Okay, we'll stop it. And it is line B. Let's see if you got that. Cool, you did. All right. Now let's look at the next one. I'm going to start it right now. It's just your next question. Which line is the point of averages on? Line A, line B, or both? Which line's the point of averages on? Now I'm curious what, because your name's Gustavo, right? I'm curious, yeah, the Valentine boy, right? I'm curious what you're going to do tonight. What's your big... What your plans are. All right, I think time to stop. And I hope you answered B. Let's make sure you did. I mean C, both, yes. Got you scared there, huh? No, both. Very good. It's that point. It's on both. Okay, now this one's a little bit harder. How are you going to do this last one? Think about it. Estimate the correlation coefficient R. And look at your hint. You have to compare the steepness of the two lines. That's hard. Imagine starting at the point of averages and going over. I don't care how many standard deviations. Let's just say pretend this was 1. If you went all the way up and they were the same line, it would be a correlation coefficient of 1. How far, what fraction of the way is B on your way to A? You know what I mean? Rise over run. Whatever run you do, how far do you rise up? Compare. If A was 1, how far, what fraction of the way does it take you to get to B? That's what I want you to guess. So let's stop it. This is a hard question, and we'll see what you said. Everybody vote? I'm very curious what you said here. Most people said C. I would too. Some people said, C is right. Let's look at the next slide and you'll see why. If you go to the next slide and look at this. Think about it this way. There's a beautiful slide here. Thank you for doing that. You go over whatever. You're just making a right triangle. Slope is rise over run. So you want to see what fraction of the way, comparing those two steepnesses, what fraction of the way how steep B is compared to A. So do you see how it looks to me as 0.55? Do you understand? If the correlation coefficient was only 0.1, B would be a very flat line, almost just a slight incline. If the correlation coefficient was 0.9, a very strong correlation, B would be almost as uphill as A, almost. If it was negative, it would be the same thing, but going downhill. So do you see why it looks like about 0.5? Those who chose 0.25, you're thinking of a much more gradual slope here. And if you say that the slope of the ST line is 1 over 1 in z-scores, or standard deviation of y over standard deviation of x, then the slope of the regression line is not as steep as that. It's R. If it was in z-scores, it would be r. If it wasn't in z-scores, it would be r times the standard deviation of the y, r, just a fraction of that, like half of the standard deviation of the y, over the standard deviation of x. All right, so let's go back to the overhead. Questions on this? So people did very well on that, by the way. And let's go back to I'm very pleased, to the document camera. And now we're going to look at just doing these regression estimates with exam scores. And you know what? When you're doing these regression estimates, you need 5 summary statistics. We've been using 5 summary stats. It's a point of averages, the standard deviations, and this. That's what you need to do these. But we haven't made any assumptions at all about the data. I bet some of you are thinking, since we're changing to z-scores, that we have to have a normal distribution for x and y. We don't. You can take any kind of crazy distribution of x or y, it doesn't have to be normal, and you can make a scatter plot and compute the correlation coefficient and make these regression estimates. They don't have to be normal, even though we're using z-scores, and you think of z-scores as being used with the normal curve, because they usually are. But we're not making any assumptions at all about what the data looks like. All right? So, here we have 2 sets of scores. Now, suppose a student is picked at random. What would be your best guess for what he got on exam 2? Like, I just picked somebody out, totally out of the blue, like you right here. And pretend we had the exam 1 and the exam 2. Now, what would you know nothing about her? You're people who aren't her friend or know, just pretend you know nothing about her. What would be your best guess just looking up at the data for what she got on exam 2? What? You don't know what she got on exam 1, you know nothing about her. What would you guess? The average. Yeah, what else would you guess? Why would you guess anything higher or lower? Because most people are at the average. So if you don't know anything about her, you'd guess the average, 70, because it's the average. But now suppose I gave you another piece of information. I told you that she actually got a 90 on exam 1 on this, so that's clearly above average. On this exam with an average of 80, she got a 90 on exam 1. Would you still guess that she got a 70, that she's on exam 2, would you?
No.
No. Why? Because it's a positive correlation, which means that people who are above average on one tend to be above average on the other. So you would guess higher. Wouldn't you just intuitively guess higher, everyone? Yeah. And if I told you she got a 40, wouldn't you guess lower intuitively? Because you know they're related in a positive way, linear relationship. So what would be your best guess? Well, we know how to do this now. We can't just say, I don't know, just higher. We know how to do this. And how we do it is we can start at the exam 1 score, and we want to get to the exam 2, but we know that we have to first go through what? We can't go directly from there to there. They have different averages and standard deviations. What do we have to go through first? Z-scores. So we have to go through the Z-score for exam 1, and then the Z-score for exam 2. Okay? So let's start here at exam 1. And the score is what? 90. So we have to change it to a Z-score, so what are we going to do? Minus 80 and divide by 10. So there's 1. Does that mean I'm going to give her a 1 here? If there was a perfect correlation, but now I have to add what's going to separate these two. What's going to separate them is R. And R here is 0.6. So what we have to do is and notice how R, if it was 1, she'd have the same Z-score, but anything else, she's going to get closer to the average than she did here. Because we have uncertainty. And so more people are at the average. So what our best guess is always a mixture of her z-score and some mixing in of the average, lowering her towards the average. So this is a z-score of 0.6. So now we want to change that to an exam score, so we start at the average for the exam score. So what should I write here? 80 or 70? I want to say, okay, exam, this is her z-score, but I want to start at 70. That's the average. Isn't that the average right here for exam 2? I don't want to start at 80. We're at exam 2. So I say plus 0.6, and not 70.6, but 0.6 of a standard deviation. Now what do I want to put in here? Which standard deviation? 10 or 15? Which one? 15, because we're at exam 2 here. So does that make sense to everybody? So my best guess for her is 79. All right? Now let's try this one. A student got a 65 on exam 1. 65, let's follow the same pattern. So what would we do that now? 65, what would we do? Minus, you tell me.
Minus 80.
Divided by?
10.
And now, be careful, this person is below average, so it's going to be negative 1.5. Sorry, I didn't line it up well. And I'm going to multiply it by what? 0.6 to get this z-score. Sorry, I made it really messy. But this z-score is going to be what? Negative 0.9. So this is a z and this is a z. And now I finally have to get the exam 2. I finally have to get exam 2. So what do I want to do? I start at 70 and I add what? Negative 0.9. And am I done? Did the person get a 69.1? No. I have to multiply this by what? The SD, which is 15. So I have to subtract from there. Oh, what do I have to subtract? 13.5, correct? Isn't that right? 13.5 from 70 will give me a 56.5. Now some of you are probably looking at that and thinking, wait a minute. You said that it's going to bring her this person closer to the average. Their z-score, look at this is one z-score and that's the other. This is a better z-score than that. It's closer to the average. This is really far below average. Isn't this a better z-score? Isn't it? So why did she end up with a worse score? She started with a 65 and ends up with a worse score. Did we make a mistake? Here we knew she was going to end up with our best prediction is going to be closer to the average, and it is. So can somebody help me out here? Did I make a mistake, or why? Is this really closer to the average? Is this a better score? This is certainly a better score. Did I make a mistake in here? You see what's happening? This is a better score relative to everybody else. Do you see how the average is much lower here? So this really is a better score, even though it looks worse on an absolute scale. All right, let's turn the page, and I apologize for that being messy. I'm going to start being neat now. Now, I just told you that you don't have to have a normal distribution for either variable to do a regression estimate. You don't. But if you happen to have a normal distribution, there's an added advantage in that you can do percentile regression estimates. Without knowing averages or standard deviations or anything, if there's a normal distribution, then the percentile will tell you exactly where on the distribution somebody is, say for an SAT in math. And if you knew the correlation coefficient, then you could make a regression estimate predicting where that person would be on what percentile they would be in their verbal. And all you need is R. You don't need any of those 4 other summary statistics. So regression estimates for percentiles, you can only do these yeah, because you can't see anything. I'm just writing to myself otherwise. Thank you. He says it so politely and said, hey, move it down. I can't see anything. Could you move it down, please? So nice. Only do these when both variables are normally distributed. You can't otherwise. And then for these, you only, for these percentiles, you only need R. You don't need the 5 summary statistics, which you do for all the other regression estimates if they're not percentiles. If you're doing what's called individual. You only... Okay, so you'll see why. Well, that's what I say right here. The key idea, again, is to convert what? Into a z-score. You can't go directly from percentile to percentile. You have to go through the z-scores. And doesn't this sound familiar to you? From what we worked with before with z-scores, converting z-scores to percentiles? Okay, so here's z and z. So, how are we going to do this? Suppose somebody was at the 80th percentile on their math, and you wanted to make a guess about how well they're going to do on their verbal, and you knew that the correlation coefficient between the 2 sets of scores is 0.6. What would be your best guess? Well, if R was equal to 1, then the answer would be the 80th percentile. 80th would line up with 80th. If R was equal to 0, if we knew nothing, then our best guess would be the average, or the 50th percentile. So for 0.6, we know it's going to be somewhere between the 50th and the 80th, but where? So how should we do this? Let's think about it. We need to get a z-score. So what chart are we going to use? We're going to have to go to the back of our books and use this, which right away tells us what? We need to get that middle area. So which tail do we have with the 80th percentile? We certainly don't have a left-hand tail. How far are we? Do we have a right-hand tail? Do we have a right-hand tail? How far are we from the top? 20. So we have a right-hand tail. That tells us we have a right-hand tail. Does everybody see that? Raise your hand if you don't. Where 80th percentile means you're 80% better than higher than everybody else. 80%. We've got this tail. But we need a middle area. We have to draw 2 tails. So what's in the middle? 60. Very good. You seem to understand this. So we have to get z find z with middle area equal to what? So what's that z going to be? Let's check it out. I'm just going to quickly look and see. 60%. And please, so many people go over here. Go 60% in the middle. Where are we? All right. 0.85, it's a little bit less, right? We could do 0.84. Do you want to stick with 0.85? What do you want to do? 0.85. That's fine with me. 0.85. So z is 0.85. And let's draw the picture. Here's 1. What this means is 0.85 and negative 0.85 is right there is 60%. But we know that he's really in the 80th percentile. That's where he is. And that's his z-score. All right, now what do you think I have to do with that z-score? 0.85. Can I just leave it 0.85? Look at this. What am I going to have to do? I'm going to have to multiply it by what? Hello, what am I going to have to multiply it by? 0.6. And that's about 0.51. So that, and do you see how it's always closer to 0? Zero's the 50th, it's right there. It's always closer to 0. Look at it, more people are at 0. If I'm gonna have to make a guess, he's right here. Let's say you're a betting person. You have to make a guess how he's gonna do the next time. Are you really gonna guess out there? I mean, everything else being equal, you could, maybe you know the person's really brilliant and you would guess, but if you didn't know anything, why would you ever guess out there where there are fewer people on the tail? If you wanted to maximize your chances, you'd always, he's above average, you're not gonna guess way down there, but you're gonna be closer to the average because look at the hump of the people there. That's where most people are at. So you're gonna lower it towards the average. If he was perfect correlation, he'd be right there, but no. Our best guess is closer to the average, 0.51. So now we mark that, right halfway and halfway, there's 0.51 and negative 0.51, and this is the person's percentile. It's going to be less than 80th. Less than 80th, but how do we get it exactly? Well, we have to look at the table in the back and look up 0.51. You want to do that together? 0.51? Look up 0.51, and what does it say? 38 for 0.51. But 38, since it's a little bit higher, we know it's a little higher than 38.29, I would go with 39, okay? Does that make sense? Because if it was 0.50, it would be 38.29. It's a little more than that. I probably wouldn't mark it wrong, but I would go with 39. Okay, so let's go with 39. 39 where? That's 39. Is that his percentile? No. His percentile is the entire shaded area. So we have to think that this is what? 61%. 61 together, so it would be 30.5. We have to add all that together. 30.5 plus 39 is 69.5%. And notice, you see, we predicted that he'd be a lower percentile, between 50th and 80th, and he is. Now look at the corresponding thing I did here. We really don't have to take it from scratch. Look at the 20th, how it matches up. I really want you to see this. These two sum to 100, and they're opposites. This person is 20 from the bottom. You're given the left-hand tail. 20 from the bottom. Here you saw right away the person was 20 from the top. So this person is just as slow as this person is fast, just as low as this person is high. They're opposites. And if we drew in the other tail and the 60, we're going to get the same exact picture. The only difference, and I look up 60, and I would get Z, and if you're not careful, you could do the same thing. But what this is telling you, this 20, is that the person, when you make this middle area and draw it in of negative 0.85 and 0.85, and draw in and think about really how many people are lower than him, you'll see it's a dramatic difference. It's not 0.85. What is it? Minus 0.85. Minus. The exact opposite. So now what happens? When we multiply by 6, we get minus 0.51. And we end up with the same exact picture here. Same exact picture. But here, the person, watch, this is interesting. The person is getting closer to 0 from the bottom, negative 0.51. Why? This person's very low. It's possible you know this person is terrible at math and you think he would be worse the next time, but generally speaking, if you didn't, you expect there's more people who are up here. So if there was a perfect correlation, he'd be back up at the 20th, back down at the 20th really low, but you expect him to have a little more good luck because most people are up there. So you think he's going to, your best prediction is he'll rise, he'll be a higher percentage. And sure enough, this percentage, he rose. Not that he rose, but that our best guess for him is that he will. And it's not because we think, oh, he bought for some psychological reason that the poor person did so bad the first time, they're going to study really hard, although that could happen and add to the effect. But even if that didn't happen, just by the nature of the distribution, by the math of it, the chances are he'll be higher. So that's what we see there. Now, I think since it's Valentine's Day, I'm just going to let you go early so you can plan your night.